In this video, we'll be learning about dictionaries in Python. Dictionaries are one of my favorite data structures, and I can't wait to tell you about them. By the end of this video, you'll know how to create and use dictionaries. You'll also recognize common dictionary pitfalls while understanding the inherent limitations of an unordered collection. Dictionaries are simply one of the most useful data structures when programming in Python. You'll find yourself using them all the time. Dictionaries are just Python's term for a map. If you've worked in Java or C++, you've likely worked with a map interface, and you likely did so with a hash map implementation. A dictionary holds a combination of key-value pairs. Here, the keys are fictitious student IDs and student names. This is something you might maintain for the students in a course. You can use this data structure to ask if a student ID is in the dictionary, and you can look up a student by their student ID number. Speaking of lookup, dictionaries are also super fast at doing lookups, which is one of the many reasons people like using this data structure. In this example, we have a string key and a string value. The only restriction on types is that the key has to be immutable. Let's look at some more examples. Here we have a mapping of courses to the instructors who commonly teach that course at UCSD. Notice that the value here is actually a list. You could even have the value be another dictionary. Any object is fine as a value in a key-value pair, and remember, everything in Python is an object. One more example. What if we wanted to keep movies and their associated user ratings? Well, we can't just use the name of the movie as the key because different movies have the same title. For example, Ghostbusters was the name of a 2016 movie and a 1984 movie. So how could I keep these in a dictionary? Well, I could use the year to help disambiguate, and I could do that using a tuple. Here's what this would look like. The key is a tuple, which is both the name of the movie and the year it was made. Tuples can be keys because they're immutable. Those keys then map to the rating of the movie, which I borrowed from IMDb's current ratings. I could honestly spend an hour just giving you more examples of how key-value pairs are useful, but that'd probably be overkill. So let's dive into how to create and use dictionaries in practice. Just like with the previous data structures, let's start by creating one. Here, I've created a dictionary with just the two Ghostbusters movies and then displayed it. Notice the curly braces when declaring a dictionary and the colon, which denotes the break between a key and a value. Next, let's look up a value using a key. To do that, we just use the brackets and the key like an index for a list. Lastly, we can use length, or len, to check how many elements are in the dictionary. To add to the dictionary, we can just use a new key as an index, and then assign it a value. So it's actually pretty easy to add to the dictionary. If Cars 2006 were already a key in the dictionary, you just reassign it. No errors are thrown. Now let's inspect the contents. We find that Cars was indeed added properly. But if you're wondering why Cars is in the middle and not at the end, that's what is meant by dictionaries being an unordered collection. There is no inherent ordering of the items in the collection, and you can't trust its internal ordering not to change at any time. The lack of ordering is part of the reason dictionaries offer such fast performance. But if your problem requires preserving the order in some way, dictionaries may not be ideal for your problem. To get back a value for a selected key, you can use brackets like I've done here. But you need to be careful with using this form of bracket access. What if you ask for a value for a key not in the dictionary? That will actually cause a runtime error. So what's a safer way of getting values from a dictionary if you aren't sure if the key is present? There are two approaches which can help. The first is to use the method get to gain access to a value for a specified key. Here, when the key is in the dictionary, you get back the value just as you'd expect. But if the key isn't in the dictionary, we get back the value none. You can then use the test is x equal to none to see if the element was in the dictionary. Similarly, you can also use the keyword in to test to see if a key is in a dictionary. Depending on your use case, you'll likely want to use either get or in to test to see if a key is in a dictionary before accessing the element in the dictionary. The key point is to be careful with using brackets to access values in dictionaries if you aren't 100% sure the values will be in there. We can also remove items from a dictionary. I've set up the dictionary to have all 3 movies from our last example. Then I use the method pop to remove from a dictionary. Here, I'm removing the 2016 Ghostbusters movie. Pop will return the value associated with the key, which is why I returned 5.4. It'll also mutate the data structure, so there's no longer the key in the value that you just popped. If we check, the dictionary no longer has the movie we just popped. You can also use the del command to remove a key value pair if you don't care about getting the value back. Just like a list or tuple, we can also iterate over the elements in a dictionary by saying for I in dictionary. Here I'm printing all the keys. If you want to print both key and value, you'll want to do this. The call to dict.items returns a list of tuples with key and value. By saying for key, comma, value, I'm asking to split each tuple into a separate key and value. Then I print the key and value separately. I'm mainly showing this so you know how you might get either the key or the value or both. You cannot mutate a dictionary object while iterating. If you do, you'll get an error at runtime. It's generally a bad habit in any language to mutate a data structure while iterating through it. The reason for this is that the underlying data structure implementation may change its structure of the data when you add or remove from it. If you ever find yourself writing an iterator for a data structure, something we do in our computer science classes at UCSD, you'd see how problematic it would be if you were trying to iterate while items are being added or removed. That said, what do you do if you, say, want to go through the entire data structure and find everything meeting a criteria and then remove those items? To do that, we'll accomplish this in 2 steps. In the first step, I'll go through the dictionary, finding keys which match a criteria. Specifically, I'll be looking for movies which were made before the year 2000. I'll add those items to a list, and then in a second step, I'll remove those movies by iterating through the list. Let's walk through this in detail. First, I've created an empty list called toRemove. Next, I'll iterate through the keys in the dictionary. Third, I'll check to see if the second element in the key tuple, the year, is less than 2000. If it is, I'll append the key to my toRemove list. Now, in our overall step 2, I'll just iterate back through the toRemove list and remove the keys in that list from the dictionary. When the code is done, we can check the dictionary and find that the movies before the year 2000 have been removed. I should know that there are slightly fancier ways to do this, but I find this way to be considerably more readable. To wrap this up, I hope you see now why dictionaries are such a fantastic data structure in Python. Going forward in the course, we'll be working with some data structures optimized specifically for data science, so you might not be using dictionaries as much as you would be if you were just programming in Python alone. But I bet you'll still find them pretty handy. In the next video, we'll see how to use list and dictionary comprehension to quickly build useful data structures.